So we have a very interesting question. A machine gun mounted on the top of the tower, 100-meter high. At what angle should the gun be inclined to cover a maximum range of firing ground below? The muzzle speed of the bullet is 150 meter per second. Take G as 10 meter per second square. So in this case, a gun is mounted at a height of here a gun is mounted and it is fired like this, and suppose it hit the ground at point A. So its initial velocity is given as u, angle of that projection is theta, and it is mounted at a height which is given as 100 meter. And let us suppose that this R, this is the origin O, and R is the range from the ground. Now we can divide this initial velocity component as in the x as well as y. So we can write u of x is equal to u cos of 30, and u is given as 150, so this will be 150, sorry, cos of theta, and u of y will be equal to u sine of theta, so it will be coming as 150 sine of theta. So if t is the time taken by the projectile or bullet from, let this be point B, from B to A, or we can say t is the time of flight. So if t is the time of flight, then the horizontal range, horizontal distance covered in time t horizontal distance, which we have denoted as r. So r will be equal to horizontal velocity, that is ux multiplied by time t, and ux is given as 150 cos of theta multiplied by t. This is the horizontal. Now motion in the vertical direction. So in vertical direction, we can take u of y as minus 150 meter per second, or sorry, u of y will be equal to minus 150 sine of theta meter per second, and distance, that is it is going to travel in the vertical direction, so we can write distance will be equal to plus 100 meter, and acceleration due to gravity equal to plus 10. So we can find out that by using the equation of kinematics, s of y is equal to uy of t plus half ay t square, and sy we already know is given as 100, plus uy is minus 150 sine of theta plus half, it is given as 10, here t, and this will be t square. So this will be a quadratic equation in t, so we can write this as t square minus 30 sine theta multiplied by t minus 20 is equal to 0. So we can use the formula for finding the roots of the equation, which will be minus b plus minus b square minus 4ac and divided by 2a. So this can be written as 30 sin t plus minus square root of, we get this as 900 sin square theta minus plus, that is 80 divided by 2. This can be further solved as t is equal to 15 sin theta plus minus square root of 2 to 5 sin square theta plus 20, taking only positive value, we get t is equal to 15 sin theta plus square root 2 to 5 sin square theta plus 20. So the horizontal range, we already found out that r is equal to horizontal component of the velocity, that is 150 cos of theta multiplied by t, and t is given as 150, not 150, 15 only, 15 sin theta plus square root of 2 to 5 sin square theta plus 2. Now there is a basic concept of the horizontal range, which states that horizontal range will be maximum when theta is equal to 45 degree. But this is the case when the projectile is projected from ground to ground, like this. In that case, for r maximum, this theta will be 45 degree. But in the other question, it is given that it is being projected from the height, certain height, which is given as 100 meter. So, but we can write it here, but we can say equation 1, but the equation 1 is only feasible for ground to ground or level to level, at the same level, we can say it, for at the same level. So in the given question, the gun is fired from the height of 100 meters. So we can say that R will not be maximum at 45 degree, but it will be close to 45, but close to 45 degree. So we are going to take various values of theta and calculate R for each value of theta. So let us take, this is theta and this is R. First value of theta we take as 45 degree, and value of range we calculated, it will be 2347. Next value of theta we take it as a 43.5 and value of range is 2347.7. Next we take it as a 44 degree and range is 2348. Next we take as 45 degree, range is 2346, and last we take, sorry not last but second last, 46 degree, range is 2341, and last we take it as 47 degree and range is 2334. So we can clearly say from here the range increases up till here. Here is increase, but then after that it start to decrease. So it means maximum range will be somewhere in between these two values. So in order to find out the maximum value, so R will be maximum, R will be maximum for theta is equal to 43.5 and degree and 44 degree. So what we do, we find out their mean. So we can say that taking mean of theta, it means 43.5 plus 44 divided by 2, and this will be coming as 43.75 degree. So the range at the ground level will be maximum for value of theta, which is 43.74, which is close to 45 degree. Thank you.